Example 4 from the Substitution and Elimination for Nonlinear Systems lab. We have the following system: x squared plus y squared is equal to 13 and x squared minus y is equal to 7. I'm going to use elimination to solve for this. So I want to eliminate a single variable, either x or y. I notice that x squared and this x squared are very similar, so all I have to do is multiply -1 from either equation and I can eliminate it. So I'm going to do this bottom one by -1. I'm going to multiply this -1 throughout this entire bottom equation. So the top equation is x squared plus y squared is equal to 13, and distributing this -1 throughout the bottom equation, we get negative x squared plus y is equal to -7. I'm going to add everything. So if we add x squared and negative x squared, they cancel, and we get y squared plus y. We cannot add these. We can't write, for example, 2y or 2y squared because they're different denominations, but we can write it as y squared plus y, like that. We have 13 minus 7, which is 6. So we can now solve for y. So I'm going to subtract this 6 to this side, so this is equal to 0. So you have y squared plus y minus 6 is equal to 0. Then factoring y squared plus y minus 6 is equal to 0. We get y plus 3 and y minus 2 is equal to 0. So we get y is equal to -3 and +2. So, which means we have two y's. We need to take these y's and substitute into either one of these equations to solve for our x's. So I'm going to choose this bottom equation because it looks a little bit easier without the second y squared. So we need to solve for our x. So we have y is equal to, starting off, we're going to do -3. So when y is -3, we're going to sub into x squared minus y is equal to 7. So we have x squared minus our y, which is -3, equal to 7. This is x squared plus 3 is equal to 7. Subtracting 3 on both sides, we get x squared is equal to 4. And then square rooting on both sides, we get x is equal to plus minus the square root of 4. Well, the square root of 4 is 2, so we get x is equal to positive -2. So we actually have two solutions from when y is equal to -3. So we get, when x is positive 2, we get y is -3. And when x is -2, we have a -3. So we have two solutions when y is -3. Next, we need to figure out what happens when y is 2. So we have y is equal to 2. We're going to sub into the same exact equation, x squared minus y is equal to 7, to figure out what our x is when y is 2. So we have x squared minus our y, which is 2, is equal to 7. This is x squared minus 2 is equal to 7. X squared plusing 2 on both sides is equal to 9. And square rooting on both sides, we get x is equal to positive -3, because remember when we square root this, there's a invisible plus or minus there. So we have two solutions for when y is 2. We have 3 and a 2, and we have a -3 and a 2. So altogether, for this system, we have 4 solutions. When y is -3, we had 2, -3, and -2, -3. And then, when y is 2, we had 3, 2, and -3, 2. And I'll show you what this looks like graphically. So if we graph these equations, we see that one is a parabola, the other is a circle, and they intercept 4 different times. So we have -2, -3, we got -3, +2, we've got +3, +2, and we have 2 and negative 3, which is all the solutions that we previously found. And so we have found all 4 solutions for this